Right. Okay, so the second one we want to look at today is the flyweight, right? So the flyweight, as we just start explaining, so an object could have states, as we said. I mean, if it's a user object, it could have name, address, and blah. So those are the values of the object, and the values changes, the state changes. The flyweight object, in this case, in what we refer to as flyweight design pattern, a flyweight object wouldn't have any state. So it would be a stateless object, like Jason mentioned. So stateless object would be less heavy, which will be lightweight. So it's the flyweight object we consider as, and which is in this case become the flyweight design pattern to deal with. Yeah. So let's have a look at an example. Are we clear with those? And we move to an example.
Yeah, I was just thinking of the boxing terminology. Flyweight means light in weight. So
yeah.
So those guys who do the flyweight division, they're really small.
yeah. So that's probably that's why they named this too. I mean, yeah, it could be the reason. So flyweight means in a very less weight, like in boxing as well. Yeah, cool. Right. So how do we create? This is all about how do we create less weight objects? In this case, very light weight. So no values at all. It's not going to have any states. I mean, stateless. So those names are important to define what this flyweight design pattern is. So imagine now we're going to get into an example, and so before we had a look at the robots creation, right? So we were creating robots, and using a bridge design pattern, we saw how to avoid hierarchy, class hierarchies, abusing class hierarchies and all that, right?
Mm-hmm.
So we had a look at the bridging to say avoid abusing inheritance and create single classes, and as possible to keep the system flat as possible, as composite as possible. We saw, right? So when we're doing that, we're creating these robots, right? So imagine we're going to create the robots here as well, just for the sake of saying the robots are going to be painted on the screen, right? So we are going to create these classes now. So these objects, we're going to create them as the robots, yeah. So this is going to be our robot definition. Yeah, this is the class for the robot. So the robot, and we're going to paint it. So the purpose of creating this class is to paint it on a canvas. Yeah, to play this game. Yeah. So yeah, a game. If you're creating a game, it will need to have a canvas, right? A canvas would be a grid thing. It will have a grid or something like that. Excuse my drawing, but I mean this could be a grid of the things to be placed. So the robot can be drawn here, and it can move up, down, left and right, and things like that. Right? You could move all these into these places. So that's why we're creating this robot class. Let's create that class. Yeah. And sorry, what I'm doing. Oh, there is already a robot. Okay. Maybe let's say a game robot, right? Okay. And this thing needs to have some values, right? Because let's say direction, it can move. Direction, yeah. We can just say direction.
XY coordinates or something.
Yeah, or move up, down, left or something, yeah. So the directions the robot can move, yeah. Direction. This is the first direction is it's in. So the direction the robot is in, yeah, to start with. So let's say then, let's create the direction class. Okay, what can you choose to create the directions? Let's imagine they are always going to be up, down, left, right. Yeah, what can you choose? What can I choose to create? Very nice, man. I love to hear that. Yes, let's put it into an enum because these are all constants, right? This is now our thing, right?
Oh. Yeah, all similar.
Yeah.
Yeah.
What happened here? In class. Oh, sorry. Direction, right? Yeah. Maybe I'll just. No, I think it's just with comma, right? Yeah. So what's the problem there then? Maybe they're not used. Okay, cool. Let's say he is facing left. Cool. Yeah. So the first, when I'm creating a game robot, the default, the direction every robot should start with is left. Yeah.
Yeah.
Just imagine that, right? And then we might need images to draw when the robot moves left, how would it look? Yeah. When it goes here, how would it look? When it goes there, how would it look? When it goes there, how would it look? So we would need a lot of images to represent the shape or the robot animation will be in, right?
Yeah, the way it's facing.
Yeah, where it's facing. Yes. Yeah. So so here we can say direction images or something. Yeah. And let's put all our images into it, right? So just thinking, I mean, they are in string format, and these could be no, let's say these are files. Yeah, we can use a file, and then file string dot png comma. So file left, right, up. I'll get to this in a bit. Just bear with me for a second. It down. So we have all these images to represent the directions they are in, and we're gonna check them, right? So if we now write the function get direction of this get direction image or something, and if you tell yeah, if you now say let's check when now you have this direction to check, you know, what direction this is in.
Yeah.
Yeah, and add also, sorry, add all the remaining branches. Oh man, remaining, yeah. And then this would be then, if that's the case, we have this, and that's a list of no dot. Oh no, actually that 0 up. No, up is here. Then put it in that same order then. Up first and down, and then left and right. Yeah. So up will be the first one, down will be the second one, left will be the third one, but because of the indexes, you know, we are one down. Yeah.
Okay.
In the list, you know. Yeah. Cool. So you see, I've stored these files, yeah, as you know, where my actual images are, which are PNG images in this case. These are my files, and I'm saying the game robot has these direction images, and whenever I want to draw this robot on the screen, I will call this function, and this will figure out, you know, what the direction this is in. This is already in left, so it will see, okay, it needs to give me the left image. Yeah, you see, you know, we just simply created a robot class to work with how to draw this robot and according to what state he's in, right? Yeah, simple as that. So we are drawing that guy. Yeah, right. So that's one game robot. And then now you say you are in the main function and you need to create so many robots this is how I'm explaining the problem, and then let's see. I mean, how to make use of flyweight objects to solve the problem. So on a game board, there will be so many robots. Sorry, there could be so many robots sitting, right? And when you load the game, you need to create all these objects to paint or draw it on your game board, right? So I mean, so now say I'm gonna create these guys, so robot one, I could probably call game robot. Yeah, I'm creating the first robot, and imagine I'm creating 10 of those. Yeah, this will be the second one, third one, and so on. Yeah, you get the idea, right? So imagine there are 4 of them I'm creating. Yeah. So when I'm creating, can you see a problem? What the problem is going to become? So I create this game robot using this class. What I'll do is I'll create this, and then secondly, I will create another one. Why? Okay, can you see we are unnecessarily creating something which is going to bloat our system? See, when this gets created, we will set this direction up as left. Oh, okay. And then, okay, let's say, I mean, we can have a function to set the direction too. Yeah. Set the default direction, right? I mean, to start with. Um, Next direction, and let's make this bar so that I can set it.
Yeah, so it can be changeable. Yeah.
Yeah. Okay. Yeah, so that can be changeable, right? Your new direction now. Yeah, no, because it's just getting confusing which one to set. Yeah. Okay. So I can now call dot set direction as I want this to be starting with up or something, whatever, and then the rest of them could also have the same. So when I'm creating and I'm setting the directions as well, I want this to start with left. I want this to start with down. I want this to be top or something. No, what is it? The right, yeah. Yeah. So I'm created all these objects with their default direction set as well. But every time they are set and define our call, I can now then call get direction as well, right? No, sorry. On the R1, I can call. So R1 dot what? Okay, hold on. Why can I call that? Oh, sorry. No. Call this there together, and then it's not gonna create the object, I think. Yeah, and then R1. Yeah, okay. So I can do that, right? Yeah. Sorry, I shouldn't be calling this there because then it won't return us the objects. Yeah, I went too concise with Kotlin.
Okay.
Yeah, so we can do all the we can do these. So we create the object R1, we set the direction to be up, and then we get the direction, right? So the direction image. So if it's up, it will get the image this. Yeah. So if you repeat that for the other ones, the problem is every time we create this game robot class, this is going to be created as well. You see all these list of images, and imagine if there are 1,000 of them. 1,000 of those images are going to be repeatedly created for this many number of times we're creating the objects. Yeah, the robots. Yeah. So our system will start bloating because we're going to store this many files created for each single time the robot is created. Yeah. So if we create 10 of these, it's going to create these files, which are 4 of them 10 times. So 40 times these files will be put into the memory, right? So you will see 4 of the app.png the list of these files will be created 4 times as you create these objects. Yeah. So you will have 4 lists containing this up and all these images again and again. Yeah. So it's going to be bloating our memory. Yeah. So we are unnecessarily creating these files, which are the list of images we need to identify the direction image. That many times you create the robots. You see the problem, right? Guys? Yeah, Jason?
Sorry, no.
You haven't got it yet? Okay. See, right. Okay. I'm creating this object, which is this game robot. Yeah.
Yeah.
When this getting created, this will be created too, because this is where it's initializing a list. Yeah.
All right. Yeah.
Yeah. When we initialize a list, it needs to put all these files into a list, which is the up, down, left, right PNGs. Yeah.
That's right.
Yeah. So this list is going to contain all these files 4 times, four files. Yeah. But that's one creation of an object. Second time, when you create the second object, the same is going to be repeated, and this is going to be repeatedly created again with the list of 4 files. So can you see the way the list is getting created again and again every time you create the game object, the robot object? Yeah. So if you have hundreds of them, we're going to repeatedly create in this list 100 times, holding 4 files into it. So that's going to become bigger and bigger.
It's going to be very expensive.
Yes, expensive, So how do we get rid of this problem? That's when, we need to think of creating flyweight objects. Let's create a flyweight object now, right, to solve the problem. So we can simply use our singleton. Remember the singleton friend we looked at?
Yes, that's right.
Yeah, so we can now call robot images or something, and we say keep this in memory only for once, so, and we can push this into this. So we have now all these images can be accessed through a singleton class, and because they don't change, we can say, yeah, that could come from a singleton too. And now you can say the direction images will be coming from an object, the direct images, right?
Right.
Done. So now every time we create the game robot, which is this class, this is going to be referring to a singleton, a flyweight object in this case, because this object is not having any state. It is having a variable, which is the direction measures, and it always a constant. It doesn't change. It tells where the images are. That's all. It doesn't change. Yeah. Every single time when you access it. So it's a flyweight object in this case. This is a flyweight object. So having the singleton with a flyweight object, we have achieved bloating our application with memory. Yeah.
Right.
Yeah, that's the pattern here. So this is the flyweight. Yeah. See?
Yeah, so that is basically, if I'm looking at my thing, it's keep the same instance throughout the whole application.
Yeah. Yeah. And plus to have a simple object, a lightweight object, which will always give me the the list of images. Always give me the list of images.
Yeah, yeah.
Yeah,
so it doesn't bloat the application.
Yes, correct. And also it doesn't have any state, right? So it only knows, what is the direction of images list. So it always tells me it always gives me the list of direction images. And other than that, it doesn't do anything. It's just sitting there throughout the whole application because it's a singleton as well. Yeah. So we can get that through this flyweight object, the direction images. Anywhere I want, but which will be always giving me the list, which stays the same. Yeah. Yeah. So in a case like that, so if our application becomes bloating, because of it, I mean, we are getting hold of a list or something like this. In the case, we saw, we should push them into flyweight objects, so that, I mean, they will always just stay the same, lightweight as, Yeah. So this is one of the purposes, which we can tell it an example. Yeah. Cool.
Yeah.
Yeah. That's about it, really. Yeah.
Yeah. No, I understand it now.
Yeah, but when you create your flyweight objects, just be careful with the values you store here. You want them as vals, because you don't want this to be mutating. If this gets
Yeah.
mutated, then what's the point? I mean, this cannot be staying as a stateless object, right? If the value here, which are the images list we hold, if they start changing, the object state will be changing. Then it cannot be in a singleton. It wouldn't serve the purpose as staying stateless. So always make sure that, I mean, it has vowels rather than vars.
Yeah.
It stays the same. Yeah, that's one of the the places we need to care about. Like, I mean, we shouldn't. If a flyweight object is having a var and something is getting changed and all that, it's not a flyweight object, because it's becoming then stateful, isn't it?
Yeah.
Yeah.
That's right.
Cool. Yeah. That's all. So we can commit this. Yeah, so we can say accept the the rather in the list every time the object is filled. Yeah, you get it right. So in this case, access the flyweight object to get the direction images, rather creating the list every time when the object is created, right? Yeah. So you get the point, right?
Can you just put a definition at the top, like you
Yeah.
done was, like what the actual flyweight is, and
Yeah. We can do. I've
yeah,
started doing that, so I've started putting them on top, So
I know it really did help me to
yes,
just
yes,
when I
right.
saw it, it kind of
Yeah.
solidified.
Mhm. So yeah, let's say, oh
Is that another?
yeah. Fly objects are stateless and are used to um keep them as lightweight. So flyweight objects are stateless and are used to keep them as lightweight. Is it more, is it understandable, or a bit more explanation needed?
Flyweight objects are stateless. Yeah, that's the good one.
Yeah.
And are used to keep the objects
Yeah.
lightweight.
Yeah.
Yeah.
Yeah. So they're lightweight. Lightweight means, I mean, it doesn't have much states and nothing else. Yeah. That's why they are flyweight, I mean. Yeah, less weight or lightweight.
Yeah, that's good.
Yeah. Yeah. So it doesn't grow in memory, they're simple, lightweight, less weight object. Just a list it's storing. It's getting access to. That's it. Yeah. Cool. And then facade. So facade will be facade will be class or a class or anything. No, and maybe let's just make it more abstract. So a facade will be an object to access a complex system behind. Yeah. What do you think?
Yeah. Facade will
Be an object.
Facade will. What's that one? A facade will something.
Will be an object to get. Sorry. Facade will be an object to get access to a complex system behind. That's it. I'll maybe probably word a bit more, by reading.
Okay, yeah, no problem. Yeah, you can take out behind and just stop at system then.
Yeah, a facade will be an object to get access to a complex system. Yeah.
Yeah, that sounds good.
Yeah. Cool. Okay, let's commit this, and I'll probably, I mean, if I rethink of the wordings and stuff like that. If I think of better wordings, I mean, I'll put them. But at the moment, this is what we are committing. See, I'm committing this now, so I'm committing to the GitHub project. So adding.
Oh, committing changes. Yeah.
Yeah, correct. Yeah, adding facade and Flyweight. Yeah. Flyweight. Cool.
Yeah. Flyweight.
Yeah. Yeah, that's it for today. That's it. That's all, man. And we have one more to finish the what is it? The behavioral, sorry, structural pattern, and then we can start the behavioral. Behavioral also have five of them, and then we're done. And knowing these, even the names exist, which is I could say, which will definitely lift us up,
Yeah, definitely. No, but we've gone through so many. I didn't even know there was so many.
Yeah, there are, man. There are these, at least. I mean, all of them. So structural, all of these. So one more to finish the structural, and then we'll go to behavioral. This is
so creational, structural, and the next one, did you say behavioral?
Yeah, this one. We're going to fill in.
Okay. Yeah. Nice.
Cool. All right then. Cool, man.
Thanks very much.
No problem. I'll we'll look at the Android. We'll fix the time, Jason. Yeah.
Yeah. No worries.
Yeah. Cool. Yeah. Okay, Jared. I don't know. We are spending time during our nighttime here, Jared, to look at some Android, development. Jared. Yeah, but I mean, after we finish these, we can probably, me and Jason, we can start the Android again with everyone as well, with you as well. But we are doing it at the moment because of we need to put up a project, so we need to build a sample app, to see something quickly, so that yeah. It's fine. We did that kind of preparation, but we'll come to Android development later as well, after this, if you want to study a bit more. Yeah.
Okay.
Yeah, that's about it really. Thanks, guys. Enjoy your Saturday evening.
Yeah. Nice one.
I'll see you soon then. Yeah.
Okay. Thank you very much. Cheers.
No problem. No problem. Bye. Take care. Bye.
Bye.
Bye. Bye, Jared. Bye.